So James is still talking about mathematics, and I'm still harvesting tomatoes. You can see I munched one a bit while harvesting it, but that's okay.
Oh, it's awesome. Look at all the ones that survived intact.
Yeah.
The important thing is Pauline has done by far the most work and the most important work on getting these ones going and keeping them going. So she raised them, from a point where they weren't even knee-high to a grasshopper, because they're coming right out of the earth, right? And stuff like that. You have to, in this climate here, you have to start them early indoors.
Well, some people don't, but I don't know why a person wouldn't.
You'd have to depend on a longer season than normal to get much fruit off of this stuff. If you want to, and the tomatoes just keep producing and producing and producing the longer the season goes. Anyway, I can't remember when we started red lighting, and it was like on the epicycle solution. So they're talking now. They're talking about astronomy, and astronomy kind of lends itself to certain types, well, classical astronomy, and we still are suffering under it. Not really. We don't suffer under it, but it's very mathematical. The stuff nowadays, the stuff since Einstein, so Galileo and the stellar parallax. Talking about Galileo, awesome figure, and his contemporary. They haven't mentioned Kepler. Somewhere along the line they did, but maybe didn't deserve a chapter on his own. These guys were stunning what they did around 1600. It's like 400 years ago. And Kepler, like what he did for explaining that the paths, or as we call them, orbits of stars, or not stars, but planets around the sun, aren't circular as Copernicus envisioned them, but rather elliptical. Now, I'm exaggerating the ellipticity of their orbits. Venus, for example, is almost a pure circle, but not quite. It's just a little bit off kilter. And then he figured out that the sun was, ellipses have two foci, or foci, two focuses. And the sun is in one of those foci, or foci. That's what he figured out. It's stunning. And he had equations for this sort of stuff to explain how fast the planets went go, not just when, and around the sun, because they don't actually keep the same speed going around the sun. He figured that out. It's stunning. The formula is quite simple, really, but figuring it out wasn't. I think it was the former communist who turned on the communists, not too early, of course, but Koestler, Arthur Koestler. He did quite a good book on a variety of scientific discoveries and discoverers. And he had, as I recall, a significant chapter on Johannes Kepler and how he had to work through things. If you're going to make discoveries, it's hard to make discoveries if you don't put in a little work. And Johannes Kepler did. Now, here's a guy who didn't put in enough work. Albert Einstein, one of the most famous faces in the history of the world, at least the last 100 years. And Einstein sheds a little light, is how this chapter is. And folks, newsflash, especially you scientists, perk up your ears, okay? Perk up your Dumbo ears and start listening. I want you to perk them up like a rabbit's ears. I want you to start listening. Einstein did thought experiments, and they see it here, and it's probably a fair approximation to what actually happened in reality. Einstein specialized in thought experiments, not real experiments, okay? Thought experiments. Oh, what would it be like if someone was riding on a beam of light? It's just an experiment you never could do. For one thing, you couldn't go fast enough. Beam of light goes at the speed of light. Okay. Now, what is that, 30,000 kilometers per second? How are you going to get that fast? And so, yeah, he had these little fantasies, something like that. So someone once said, I think it was about politics and economics. What happens when you mix politics and economics? What do you get? Answer, economics. What happens when you mix thought and experiments? You get thought. In other words, philosophy. Might be bad philosophy, might be good philosophy. Frankly, good philosophy, that's kind of like an empty set too. What happens if you mix good with philosophy? You end up with philosophy. Anyway, so they show, this is supposed to be a rendering of Isaac Newton, looking a bit like a rubber plant or something like that, only even more flamboyant hair. But it's supposed to show Einstein's greater, I suppose, than Newton. And comes along and he adds stuff to Newton. Newton's stuff isn't accurate enough to the smallest detail. No. Newton got some things wrong. And one of the things apparently that he got wrong, I've been trying to find out exactly who came up with the idea of ether, which was something that exists in space. I don't think that Newton had the idea that I've seen ascribed to him, that ether was a medium for light. My understanding, could be a misunderstanding, is that Newton had the idea that light was a corpuscle. What is that? Corpus is body, soul is a little body. So light was just particles of light. And the sad thing is, like that was contraindicated by, or contradicted, shall we say, in this medical kind of term, but contradicted by Thomas Young. Almost 100 years later. Newton died 1727. Thomas Young was doing his experiments with light and proving that light is a wave phenomenon. About 1800, maybe 1805 or something like that. So not quite 100 years after Newton. Then all of a sudden, Einstein comes along, 1905. Hey, light is a particle, like Einstein, like Newton said, and I'm so brilliant that I can resolve that with it being a wave. Because I'm just going to wave my hand and say it's both. Hey, scientists, you get on the stick and get some experiments that prove it's one or the other. The way scientists are now, in the wake of Einstein, they keep on hewing to his party line that light is both a wave and a particle. Get an experiment, preferably many experiments, not just some experiments that show it's one or the other. Thomas Young has proven it's a wave, and then they keep saying, well, in some experiments, it behaves like a wave. And then some experiments, it behaves like a particle. So here's one thing. You bombard a metal with light, and all of a sudden, bits of, I believe it's electrons, come off of the metal. Wow, that's amazing. That proves, according to them, that it's a particle. So the light's made up of particles. So particles come in, bomb, and they bomb little bits of the metal off into hither, thither, and yon. That's interesting. Like you get a wave on the beach interacting with the beach. Like the beach ain't a wave. Might have wave-like features and stuff like that, but it ain't a wave. It's a solid. It's kind of like a composite solid. And ain't no one going to tell me, I'm doing like a hip-hop artist, goosing my neck around, gandering around. Ain't no one going to tell me that the wave coming through on the ocean, let's just say it's coming into Malibu or something like that, in the Los Angeles area, that wave is made up of particles. There are particles in there, but it's the wave that's actually giving the energy to knock sand off of the beach. See how that goes? No, I suppose most scientists, they might be hitting the roof and then bouncing down and bouncing back and forth. It might be an infinite process. Yeah. But actually that's the way it is. You cannot go around doing thought experiments and do real science. You can go around doing pseudoscience and stuff like that. But you can't do real science, and most importantly, maybe it's not that important, you cannot slip it by me. One of the things I'm proudest of is there's a picture taken of me back when I had longer hair and a bigger beard than Neil Young at the same time. About Neil Young would be more like 73, 74. But I've got it's by a blackboard in the physics department, the old physics department, the University of Lethbridge. And I've got a little pointer in my hand. And of course I got the long hair, not trimmed up like this guy. And I've got E equals MC squared, but I've got a little question mark on top of the equal sign. And I've got a big smile on my face. And I was right, even though I didn't realize I'd be right. Now, the infinitesimal Zeno of Leo, so you're going way back to the Greeks. Leah, I believe, is in, was it in Magna Graecia? Or else maybe in the northeastern part of Greece.
Okay, so I have 7 pounds of tomatoes today.
It was 4, was it the day before?
5. Yeah.
Okay, there we go. So it's ramping up, folks.
Yeah. You got to eat more tomatoes and big
Yeah.
tomato salads like that.
Yeah, I'll have some great tomatoes here with a little bit of, how much, 15?
Yeah, 17. Wow.
17. Yeah, that's close enough for rock and roll. Even though we're not doing much rock and roll. Archimedes and the infinitesimal. So here's something illustrated what Archimedes was. Understand, he died before 200
in my
BC.
pocket, so I have a little more.
Yikes! Lucky you didn't sit on a roll-on or something like that. That's good.
There we go.
Anyways, already starting to work on calculus. And then not much really takes place. They say, oh, some people were working on it, maybe, Chinese. There are a lot of people going around, especially people of Chinese extraction. I don't go around strutting around. There's William Rowan Hamilton. He was Irish, and I'm Irish, and man, oh man, the Irish are just awesome. When it comes to mathematics, they aren't. The Chinese were awesome for their time, but this guy who was working on infinitesimals, they're saying, wow, he surpassed Archimedes. Well, let's see, did he come was he like 19 or 198 BC? No. It is 225 to 295 Common Era, which is AD, Anno Domini, in the year of our Lord. So he's roughly 500 years after Archimedes' death. Yeah, well, that's not impressive. 500 years is a long time. We're talking about the beginning of the Renaissance. That's about 500 years ago, maybe 600. But when you're 500 years behind a 8 ball, you'd better be a little bit more accurate. But it doesn't make the Chinese tradition just the equal of Greek. It's actually not that good by comparison. Newton versus Leibniz, both of those guys were mathematicians. Leibniz was more of a philosopher than a mathematician. Newton more of a scientist than a mathematician. And a technologist. He's actually Sir Isaac Newton. There he is. I don't believe in the Sir thing, but he's using a prism to separate light into its various frequencies and stuff like that, showing it up in terms of a rainbow. But there apparently is maybe a re-rendering, it might be an original, of his reflecting telescope. Why do I say his? Because apparently he invented it. And I think reflecting telescopes are generally the way they go nowadays. Although they're probably being superseded by other means of registering stuff out in the air. Maybe not. Gottfried Leibniz, non-standard calculus, the French Revolution, decimalization. I suppose that helped out with science and with mathematics. marks, I suppose. Decimal time. They actually tried using it after the French Revolution. Yeah, all sorts of wacko ideas. Joseph Louis Lagrange. So he almost was wiped out by the guillotine. You know, that was left-wingers doing that, folks. Wiping out scientists, some, and thinkers, and so on and so forth. So people are going around saying, oh man, Catholic Church, Protestantism, they were whacking people, you know, like scientists, you know, like here we go. French Revolution, left-wingers, you know, many of them have been very bad, people, revolutionaries in particular. And this is pre-communist, although the terror, as Marx calls it, the Jacobin part of the French Revolution, he really thrilled to. So, yeah, and of course, Lenin, following up, he was really excited about, in his phrase, translated in English, revolutionary terror. And he kept on saying, we're practicing it, we will be practicing it. And you know, that's one political promise that the commies kept. Yeah. Okay, de Laplace, Pierre Simon de Laplace, Évariste Galois. So the story that goes around was he was challenged to a duel, or challenged someone to a duel, and he was just a young pup, maybe in his early 20s. And the night before the duel, he knew he was lousy with a gun. Didn't do enough. Did too much mathematics and too little practicing at the target range. And so he wrote, according to the story, he wrote down all his fantastic discoveries. And apparently he was a fantastic mathematician, but apparently he'd put down a lot of this stuff before his last night. So they mention Abel, Jean-Baptiste Joseph Fourier, or Joseph Fourier. So he's the contemporary of Napoleon I. Here, Napoleon is scratching his belly button or something like that in one of his typical poses. And then all of a sudden it jumps up to John von Neumann, or they probably mispronounce it, von Neumann. He's supposed to be a phenomenal mathematician of the 20th century. And we're looking at Gibbs, Joseph Willard Gibbs there. I'll show you von Neumann. I don't think he could have been that great a thinker because, I don't know, maybe he's a counter example to the idea that I've got that you can't be overweight and actually have a really, really first-rate sharp mind. Music and math, waves. Oh yeah. Robert Brown, Brownian noise is named after him. Robert Brown, looking very concerned about something. Maybe he was being subjected to Brownian noise. The wise man and the chessboard, who knows who invented chess? I don't think it was a really grand achievement. Go apparently is a much more challenging game. Last time I heard computers weren't able to beat human beings. At least the best at Go, at least the best Go competitors and stuff like that. John Napier came up with logarithms. I suspect he was something, his name seems, last name seems French, but I think he was supposed to be Scottish or something like that. Leonhard Euler, a fantastic mathematician. I think he was Swiss. The bridges of Königsberg. He lived for a while in Königsberg. I don't know if it's still called Kaliningrad. It was its name is German. Yeah, the Germans stole it from the Prussians, the real Prussians, not the later Prussian Germans. But the Prussians, the original ones, I think they were to a large extent exterminated by the Germans, but who later on called themselves Prussians. But the real Prussians were related to the Latvians and Lithuanians, so they're not even a Western European, they don't even have Western European language. Anyway, yeah, the Russians then took it over. Yeah, that's fair. No, it isn't. The Russians should give that up. They wanted another port on the Baltic Sea, or as the Germans style it, Ostsee, the Eastern Sea. But yeah, sometimes Zee can mean lake in German. It's obviously related to sea in English, but that's the way it goes. The curious math of Alice in Wonderland. Discovery of the quaternions, and they maintain that you can find quaternions in, or kind of like suggestions of quaternions in some of Alice in Wonderland. You know, what's the thing about Lewis Carroll? It's actually, Lewis Carroll is kind of like a translation of, what was his name? Charles Ludwig, what was his last name? I'll think of it. Or I'll find it in here. I'm just glitching on that. But he was a mathematician, the guy who wrote Alice in Wonderland. And apparently quite an accomplished mathematician. I don't think he was world class by any means. So quaternions were discovered by a guy I mentioned before. I believe he's Irish, William Rowan Hamilton, and it's interesting sort of extension of the imaginary numbers, the quaternions. But I think there's a way of actually getting stuff. He was trying to get imaginary numbers, or an extension that extended into 3 dimensions, but what call it quaternion, not trinion or something like that, because the numbers that he ended up with gave you 4 dimensions but didn't give you 3 dimensions. And we've got Carl Friedrich Gauss, and Gauss apparently was quite a good scientist as well as being an awesome mathematician. Here's Lewis Carroll, looking otherworldly there. Non-Euclidean geometry. I think Lewis Carroll wasn't thrilled about non-Euclidean geometry, but that's the way it goes. So it's things like, we talk about Lobachevsky, and they don't talk much about Riemann. And they don't really talk about Riemann's hypothesis. Still hasn't. I think they talk about it. It's been around for more than 150 years, and no one has proven it. Last time I heard. So Poincare disk model. I think Poincare was a scientist as well as a mathematician. Kind of nice picture. Oh yeah, Dodson. I think he pronounced it Dodson, but it should really be pronounced Dodson. So that's Lewis Carroll's real name. Dodson, the nictograph. Yeah, that was. Yeah, so it was someone in the math department who invented this. It's a way of reading Braille in the dark. Very impressive little thing. Presumably you have to write it using that little framework. So more stuff on Dodson. Way too much on Dodson. So this is when you start realizing that this is a serious, or seriously, maybe not a seriously not a serious popularization. Way too much on it. The infinite, the insoluble, and the computer. Georg Cantor. So he's supposed to have proven there's just 2 kinds of infinity. There's the infinity of the rational numbers, and that includes the whole numbers. And then there's the infinity of the real, and anything that's based in them, I suppose, imaginary numbers and stuff like that. Georg Cantor, he was much hated by one of his contemporaries, Kronecker, maybe someone a little older. Both guys, well, Kronecker was obviously wrong. He was basically saying Georg Cantor was kind of like doing witchcrackery or something like that. Georg Cantor had his ideas. I don't know. I think maybe he kind of confused cardinal numbers with ordinal numbers. I think there's a difference. When you're dealing with one, you can have different sizes of infinity, and with others, not so much. The Hilbert Grand Hotel. So David Hilbert, probably the way you'd say it. David Hilbert, a German mathematician. He always strikes me as being a little bit overrated, maybe a whole lot. But Cantor's diagonalization argument is good for what he is talking about, able to count rational numbers. Okay. But David Hilbert looking very Joycean, and wearing the hat we associate with James Joyce with glasses and stuff like that. I don't know if James Joyce ever had that full beard. I think he had. Well, he had kind of like a real dapper kind of beard, trimmed down, mustache, and maybe a goatee or something. Friedrich Ludwig Gottlob Frege. So I think philosophers are thrilled about him. The first picture I've ever seen of him. Yeah. Concerned with various problems with set theories and stuff like that. Another guy, maybe a later contemporary, much later in terms of how long he survived. He lived well in his 90s. Bertrand Russell, mathematician, philosopher, and logician as well. I'd call him more of a logician and philosopher than a mathematician. But Principia Mathematica is the second one I know of in the English language, but it's not done by an English person. I think this is done in, hopefully it's English. The original, or the original famous one, is Isaac Newton. I've got that in the original Latin. He wrote it in Latin, even though he's an English guy. And writing, well, his heyday would have been a little bit before 1666, and he died 1727. Okay, Gödel. Gödel destroys math. And I think Bertrand Russell found a way of getting over this. I mean, there's a problem with sets that contain other sets in them and stuff like that when you're dealing with logic. The thing is, you just don't have a nervous breakdown about it. So, Zermelo, and a couple of small pictures that I'm going to show you. Frankel had some things to say about that. Paul Cohen, World of the Fields Medal, a more recent kind of guy. Moritz Schlick, again, I think, Schlick, I should say. How much time?
1:30.
There we go. I'm halfway through. So, Schlick, I gather, was one of these guys who was messing around with set theory and stuff like that. I think it was more of a philosophy. Here's poor, what was his name? Alan Turing? Alan Turing was his name, Alan Turing. And, he ended up having to did he commit suicide? I think he did, but for a while there he was convicted of homosexuality, as they called it back then, in England. And this is maybe around 1960s. I was alive at that point in time. And he had to avoid a jail term, I think he had to take therapy in the form of chemicals, presumably some sort of hormones, really sick sort of thing, doing that to anyone. But this guy is apparently really good with computer theory, the beginnings of computer theory and stuff like that. So I'll sign off with Babbage, Lovelace, and the Difference Engine. So that's looks like it's one of the first computers. Grace Hopper, someone's supposed to be good at computers. 5 seconds?
10.
10 seconds. So we'll leave it at how we write it, okay?